Okay. For the opening activity, these were the same graph. These first 4 seconds show that it's 5 meters per second the whole time. And this graph shows it goes up by 5 meters and over by 1 second. And this line is straight, so it does that the whole time. From 5 to 10 in 1 second is 5 meters per second. From 10 to 15 in the next second is 5 meters per second. It's 5 meters per second for the first 4 seconds. And that's what that graph shows. Thank y'all for that. All right, here we go. So I've written all these words up on the board so that, let me make sure this is showing the right thing. Yeah, that'll be fine. Okay. All these words up on the board can be combined to describe some of these graphs. So I'm going to zoom in a little bit. This acceleration graph here, for example, I can use some of these words to describe it. So it has a positive acceleration. It's positive 10. So here we go, positive acceleration. And it's got a constant acceleration. It was 10 the whole time. Constant acceleration. There. If it has an acceleration, that means that it has an increasing velocity. So I got another one. Increasing velocity. The slope of this line is 0. So I've got 0 slope on this graph. What else? What else do I have? I said increasing velocity, 0 slope. I mean, we can say some more things if we make some assumptions, but I think that's all I want to say about this one. So I'm going to show you all some graphs, and I want each person to get ready 2 things to say, because I'm going to ask 2 questions. If I get some unexpected responses, I may ask more than 2 questions, but I'm going to ask 2 questions, one to each to different people about the graphs that I show here. So, no. Here we go. Oh no, oh no. I guess that's fine. Okay, take a minute to look at this one. I'll get out of the way. You're just looking for combinations of those words if you're at a loss here. This one's a little weird, think about it. Who's got one of those descriptors? A volunteer, yes. What you got?
I want to say that it's decreasing velocity.
Decreasing velocity would work, because you might think, well, yeah, decreasing velocity would work. It goes from 20 to 15 to negative 10 to 5 to 0. That's negative 20, negative 15, negative 10, negative 5, 0. So it's going towards 0, so you could say decreasing, because it's going real fast in the negative direction, and then it's going less fast in the negative direction. It's going 10 and 5 and 0, all in the negative direction, except for I guess 0 isn't in a direction because it's not moving. So sure, some people have said that this is increasing velocity, which would also work, because from negative 20 to negative 15 is an increase of 5 mathematically. So you can say both about this, and either is fine. But something slowing down like this that's going in the negative direction would be like a car that's backing up. So if this is the front of the car here. The car is backing up real fast and then slowing and stopping. So it's going fast, backwards, and then slows down and stops. Ooh, Jackson, what you got about this one?
I was going to say negative velocity.
Sure. It has negative velocity because it's in that opposite direction. It's going, this is like the car backing up. Negative velocity just means it's backing up, so cool. Let's do another one. Oh no. This one, take a minute to look at it. Melanie, can you see back there? All right. You got something yet? I'm a little early. Yeah, I was talking to Melanie. Dylan, you got something?
It's an increasing positive slope.
Okay, sure, yeah. The slope is increasing and the slope is positive the whole time. I mean, maybe it's zero for a little bit right there, but maybe not. I don't know. I don't think it is. So, cool. Now that may mean something else that somebody else could say. Emily, you got something about this one?
Positive velocity.
Positive velocity, good, because it's going in the positive direction. First it's 0 meters, and then 10 and 30, 60, 100. And so on, 160. It's moving in the positive direction, and the slope is positive the whole time. The slope is measured in meters per second. Distance is in meters, time is in seconds, so positive velocity. I think we might be able to say one more thing about this, if somebody else has something different. I'll do a volunteer here. Anybody think of something different?
So positive acceleration.
Positive acceleration, yeah, because it is accelerating. In these first 2 seconds, it goes from 0 to 30 meters or something like that. So 15 meters a second average. But you can see even then it's increasing. First it's real slow, and then it's kind of faster. So that's 30 meters in the first 2 seconds. In between like 4 and 6 seconds, it goes from 100 to 250. So it goes 150 there instead of 30. So it's going a lot faster by then. So sure, positive acceleration. Oh, and one thing, acceleration is never going to be increasing or decreasing, at least for our purposes, because it just makes it too crazy to analyze. Acceleration will be constant, and the other things can be increasing. Hello, it's me, Mr. Franklin. Mm-hmm. Oh, you want to come up here? You want to talk on the phone here? Okay. Amber. All right, keep going. Who's got something for this graph? That was a nice pause there. Here, I'll call on somebody. Who we got here? Brighton. Dean, sorry about that.
I can't read it. Give me a second.
Okay, we'll come back to you. You can be the second person. What you got, Melanie?
I move up.
Yeah. Yeah. Yeah, I guess that's a good idea, because we got people that have changed. What you got?
It's constant.
What's constant?
The velocity.
Velocity is constant, good. Because, I mean, there might be a few things that are constant about this. This is constant velocity. And a lot of people get confused here, because they think, like before, we've had a position graph with a straight line that's not flat, but that's constant. And they see this and they forget to just look, oh, well, this says it's velocity, and if the velocity is 0.5, and then it's 0.5, and then it's 0.5, and then it's 0.5, it's constant, it's not changing. So that's good. Yeah, we've got more seats up here. How about you, Gabe? Can you see back there? It's pretty much as big as I can write here, so. I mean, you can read these words, I guess. Well, if you have trouble seeing the graphs, then move up. You can move at least 2 rows up.
It was already said.
Emmanuel, have you said something yet? What you got for this one? I forgot about price. That's
Well,
okay.
it's constant.
Well, we already said velocity is constant, but there's something else you can say is constant. There's two more things out of these things.
Constant slope.
Constant slope. Farron, what's the other one?
Would it be like zero acceleration?
Zero acceleration and constant acceleration. Because it never accelerates. Its acceleration is always zero, so zero acceleration, because it doesn't speed up and slow down. And the acceleration is constant at zero. So that's good. Last thing I want to talk about before I turn y'all loose on the review here. We can get scrolled down here. That'll be fine. So let's look at this real quick. This is time on the x-axis and meters up here. So it's displacement. They used an x instead of a lowercase d for displacement because it's horizontal displacement. Once we start going vertical and horizontal, sometimes they'll say y for vertical displacement. I don't like to mix all that up, so I just say distance. I just say lowercase d for displacement, and then we'll keep it straight. With the question says it's going up or down, and that's good enough for me. Anyway, this little piggy goes from 5 to 10, so it goes up by 5 meters, and that takes 10 seconds. 5 meters over 10 seconds makes a slope and a velocity of a half a meter per second, 0.5 meters per second. And then it stays at 10 for a while, so its velocity is 0. And then it turns and goes back the way it came from. That's how you know this is displacement and not distance, because it knows about direction. It was here at 5 meters, and if it comes back to the same 5 meters it was at, it's got to be displacement, because it knows that it went 5 meters this way instead of just going 5 meters any which way. Anyway, this one's going faster now. This one went, let's see, from 10 to 0 meters in 10 seconds. So 10 meters in 10 seconds, well, that's 1 meter per second. Now it's in the opposite direction, so we'll say negative 10 meters per second, negative 1 meter per second. And now it's, the slope is still negative 1 meter per second, but it's getting farther and farther from a starting point down into the negative displacements. And then it turns around at the same speed, but its velocity is now positive 1 meter per second since it changed direction. I just wanted y'all to think about that. Please open up the review and yeah, try it out.